All right, today we are going to solve trigonometric equations. And we're going to work on this today and tomorrow. I don't really want to do something new tomorrow before a 4-day weekend, and I think this is something that we could use 2 days on to get some good practice in. Okay? So when I say solving a trig equation, you're going to get something that maybe looks like this. Sine of x equals 1/2. Okay? So if I asked you, what is x? Kyler, what would you tell me?
I would tell you that it's 3
Okay, well, we're going to stick in radians, so 5/6. Nathan, could there be something else that you say?
Yeah.
5/6 is the only time sine is 1/2. Think so? Hey, Sean, what do you think?
5 pi over 6.
At 5 pi over 6, our sine is 1/2. Inverse sine. Inverse sine. Yeah, for these, we're just talking about angles that are going to satisfy this equation. Okay, anything else besides pi over 6 and 5 pi over 6? What about 13 pi over 6? Would 13 pi over 6 work in this equation? It would. What about 25 pi over 6? Would that work? Hold on. I said that wrong. No? 25 pi over 6. Would that work? Okay, let's think about this graphically. Here, you don't have to write this down, but here is the graph of y equals the sine of x. Okay, if we're talking about the sine of x equaling 1/2, we're talking about every time that our y value is 1/2. Well, sine is a periodic function, which means it repeats over and over and over and over. So what's going to happen? We're going to have lots of times where that is 1/2. Okay, let's think about the unit circle. Okay, we mentioned that at pi over 6, our sine value is 1/2, and at 5 pi over 6, our sine value is 1/2. Well, if we imagine rotating around the unit circle over and over and over again, whether it be in the positive direction or the negative direction, what's going to be true about our solutions? Okay, we're going to have a lot of them, aren't we? Okay, and if we continue to rotate around the unit circle, okay, or if we think about the period of our graph, okay, the period of sine is what? What's the period of sine?
Pi.
2 pi. Okay, so since the period of sine is 2 pi, all of these coordinates are how far apart? 2 pi. All of these coordinates are how far apart? 2 pi. Okay? So what we're going to do is we're actually going to use our unit circle knowledge and our knowledge of these graphs to write solutions. Now we're not going to write pi over 6 and 5 pi over 6 and 13 pi over 6 and 25 pi over 6 and keep going. No, we're not going to do that. Okay, we're going to have a way to express these solutions, so you only have to write them once. Okay? Now, are all of our equations going to be the sine of x equals 1/2? No. Okay? We're going to have to use some algebra skills before we can use our trigonometry skills. Okay? So this is what you need to do. Okay? First of all, you need to identify what kind of function you're working with. Obviously, they're all going to be trigonometric, but do you have a linear trig function or a nonlinear trig function? Linear means what? How do I identify a linear function?
Not to a power.
Okay, we don't have a to a power. So the sine of x equals 1/2, that would be considered linear because the sine is not raised to a power. All right? If you have a linear trig function, then isolate that linear trig function. So if there's more than one sine of x, then you need to combine those sine of x's and then get it by itself. Okay? If it's not linear, then you're going to want to set it equal to 0 and see if you can factor it. Okay, there is a reason why I had you factor last Monday and then yesterday on your quiz. It is possible that you're going to use identities to help you. Okay, especially those Pythagorean identities. They're going to be of use to you. Once you get to the point where you're at sine of x equals 1/2, or cosine of x equals 0, or tangent of x equals negative radical 3, okay, you're going to have to think about the angles that satisfy the equation, okay? And then we're going to write the solutions based on all of the different solutions that can happen. So this is how I would like you to do that. I would like you to write x equals whatever your angle is. So I wrote solution. This is going to be your angle. Okay? Plus the period times n. I'll give you a chance to write that down, and I'll talk about what that means. Okay. So we want to write all of the solutions that this equation has, okay? And we know that with these periodic functions, they repeat every period, right? So in the case of our sine of x equals 1/2, okay, we know that at pi over 6, the sine is 1/2. So we would write, okay, well, our angle is pi over 6, but it repeats every period. So when you add that plus 2 pi n, if we plug values in for n, we can get different angles. Okay, pi over 6, 13 pi over 6, 25 pi over 6. Also, 5 pi over 6 is a solution. So we will want to write that as well. Okay. So you're going to sometimes have more than one solution to write. Okay? And with that solution, it includes an infinite number of angles because it's repeating over and over.
What does the N stand for?
N stands for any integer.
Okay.
So you could plug in 1, 2, 3, -1, -2, 3, and get an angle that's going to satisfy. Okay. All right. So let's go through some examples here. We will start off easy. Is this linear? Okay, it is linear, which means we need to isolate the trig function. Okay, I see more than one sine of x, so what should we do with that? We need to make it so that they're on the same side. So I'm going to add this sine of x over here. So we have 2 sine of x plus radical 2 equals 0. Now what? Subtract the radical 2. And then divide by 2. Once your trig function equals a number, you need to stop. Okay? We can't, the x is the angle of our trig function. We're not going to divide out sine. Okay? We're going to stop once we have our trig function equals a value. Okay? Now we're going to identify angles. So, Courtney, where is one place that the sine is negative radical 2 over 2? Look at your unit circle. 5 pi over 4. So we're going to write 5 pi over 4 plus the period of sine is 2 pi, and then times n. Yes.
And we're doing that because of the graph and it goes on.
Right, because it repeats over and over. Very good. Layton, where's another time where the sine of x is negative radical 2 over 2? 7 pi over 4. And that one repeats over and over again. So those two solutions represent all of our solutions.
Because there's a base of the unit circle.
Right, so we're just going to think about like the one rotation of the unit circle, and then this is taking into account that it's going to repeat over and over. Okay. All right, you ready for another one? Does anyone feel uncomfortable with this example? Why are you shaking your head, Sarah? There's cosine and sine. That's probably not good. If only there is a way to change one of those. Doesn't ring a bell? I feel like you're being sarcastic, Tyler, enlighten us.
Identities?
Okay, so what identity could we use to change one of those? We want the same trig function for those.
1 minus cosine squared.
Okay, so since we have cosine here and sine squared here, we can change sine squared to 1 minus cosine squared, and now we have the same trig function throughout our entire problem. Okay, so now we have 2 minus 2 cosine squared x plus 3 cosine x. What do we have? We have a trinomial, okay? Which means we're going to have to factor. So what we're going to do is we are going to reorder this, but I really like our leading coefficient to be positive, so I'm going to reorder at the same time as moving everything over to the other side. So I'm going to write 0 equals positive 2 cosine squared minus 3 cosine x minus 2. That way that leading coefficient is positive. Now we have a trinomial that equals 0, so we need to factor. Okay, so this is what you practiced the other day. Okay, if you need to go off to the side and write these as C's, you are more than welcome to. Okay, but I know to make 2 cosine squared, we're going to have a 2 cosine x times a cosine x. I know to make negative 2, we're going to have 1 times 2. One's got to be positive, one's got to be negative. The 2 can't go here because then there's something in common. So the 2 has to go here times the 1. Which one needs to be negative? Okay. If we have negative 2 times 2 cosine and a positive 1 times cosine, those will add together to be negative 3 cosine. Okay. Feel free to write them as C's and then factor, but go back and write them as cosines. Okay, so now what's happening? We have 2 factors that equal 0. Okay, so we have 2 cosine of x plus 1 equals 0. And we have cosine of x minus 2 equals 0. Okay, let's start over here. This just means that the cosine of x is negative 1/2. Okay? Grant, where would give me one place the cosine is negative 1/2?
2 pi over 3.
So we're going to write 2 pi over 3 plus, it keeps repeating, our period of cosine is 2 pi a. Okay. Josie, give me another place where the cosine is negative 1/2. 4 pi over 3. So we're going to write 4 pi over 3 plus 2 pi n. Excellent. Now we need to go to our second factor. The cosine of x equals 2. Why am I making a funny face? Well, it's not on the unit circle. It is out of the range. Excellent. Remember, cosine bounces between negative 1 and 1. 2 is outside of that range. That can't happen. That does not give us a solution. Algebraically it works, but trigonometrically it does not. So these are our only solutions. Makes it nice when that happens, right? Next one. This one and another one, and then you are going to be in charge for me, okay? But I got to show you 2 more types of problems you're going to come across before I send you in groups on your own. If that even makes sense. Okay, raise your hand if you look at this and you want to divide by the cotangent. Matthew's the only one who wants to divide by the cotangent. Okay, it is very tempting. But here's the deal. Let me ask you this. Could the cotangent be 0? Okay, are we allowed to divide by 0? We are not. We cannot divide by a function. Okay? So instead of dividing by a function, if you ever feel the want to divide by a function, don't. Stop yourself. Instead, you need to subtract it to the other side. That way, what can we do? We can factor it out. Okay, you cannot divide it out because you're going to lose out on some solutions. We're going to need to subtract it over, and now we can factor out a cotangent. Okay, so now we have 2 factors that equal 0. We have the cotangent of x equals 0, and we have cosine squared minus 2 equals 0. Okay. Let's see. Michael, tell me a place where the cotangent is 0. Three pi over 2. And what is the period of tangent and cotangent?
Pi over.
Huh?
Pi over b.
Good. Pi over b. So we're going to write pi n. Tangent and cotangent, you're going to add pi n. Okay? Is there another place where cotangent is 0? Amanda, is there another place?
Pi over 2.
Good. Pi over 2 plus pi n. Now, I want to warn you about something, okay? How far apart is pi over 2 from 3 pi over 2? Pi, okay? So when I say pi over 2 plus pi n, if I add 1 pi to that, we get to pi over 2, or 3 pi over 2, excuse me. So when you have tangent and cotangent, when you write out both solutions that make sense on your unit circle, they're going to be pi apart because of the period. So you're only going to see this answer in the back of the book. Because these two are pi apart and our period is pi, they're only going to write one of them. If you write both of them, I am fine with that. I don't mind you being redundant.
Isn't cotangent 0 or cosine 0? Could be pi.
No. Because it's x over 2. Right,
Cosine over sine.
right.
So it would be 0.
And
that one it would be 0 over 1. It would be 0.
this is the coordinate 0, 1. So cosine is 0, sine is 1.
Oh my gosh, I put the coordinates on
Oh, that's too bad.
my. Rookie mistake, rookie mistake.
I'm glad you paid so close attention when you checked your answer.
Well, I didn't think I missed those ones.
Fair enough. Okay, let's go over to this one. Is everyone okay with this answer over here? If you write both of them, that's fine. Just understand that the back of the book isn't going to write both of them. Okay, that's going to happen with tangent and cotangent. Okay, now over here, we have cosine squared minus 2 equals 0. So we're going to need to add the 2, and then what?
Square root.
Square root both sides. Please do not forget that when you square root both sides, we have a plus or minus attached to that number.
So 4.
So there's going to be 4 of them, right? Yep. So let's list them all. Positive radical 2. Right, man. Yeah. What? What is radical 2? Oh, it's 1 point something. Cosine can't equal radical 2 because it's outside of the range. Man, that's too bad. But if it were like positive, negative, radical 2 over 2, we would have to list all 4 of them. Okay, last example, and then I'm going to give you a job. Okay, what is different about this example compared to the rest?
It has its own variable.
Okay, well, the t instead of x. What else is true? There's a coefficient with the angle. Okay? Now, please be careful. Okay, this is linear. So we want to get cosine by itself, which means we're going to add 1. And then we are going to divide by 2. Now, we cannot divide by that 3 because the 3 is inside our function. So instead what we're going to do is we're going to identify where the cosine is 1/2, but that is where our angle, those are the angles that will satisfy, and our angle in this case is 3t. Okay? So first job, where is the cosine 1/2? Give me one place, Siobhan. Pi over 3. So our angle 3t is going to be pi over 3 plus 2 pi n. Where's another place? Sean?
11 pi over 6.
Of the cosine to be 1/2. 5 pi over 3. So we also have our angle 3t is 5 pi over 3 plus 2 pi n. So if I actually want to know what t is, what are we going to have to do? Divide everything by 3. So this becomes t equals pi over 9 plus 2 pi over 3n. And this one becomes 5 pi over 9 plus 2 pi over 3n. And those are our solutions. We can't divide by that 3 until after we write our angles out, because 3t is the angle. It's almost Valentine's Day, so I'm handing out some pink paper. Okay. What I'm going to ask you to do is I'm going to give you and your group one problem to solve. So I want you to solve it out maybe on a piece of paper first, and then I can check it, and then you're going to write it out nice on the pink piece of paper with an Expo marker, and then we're going to put them around the room for other people to see. All right? Any questions?
We're just gonna do a problem on paper.
You know what?
Like, we're all gonna help, like, are you ready? Okay, sorry.
Thank you. Yes, Chris. Get to do this first.